Okay. So in the last lecture, we have seen the idea of Spearman's rank correlation coefficient. Okay, and we have solved one problem based on this rank correlation coefficient. Okay, so let us see some more problems based on this rank correlation coefficient. Okay, so we'll have the another example. So here we have the example. We have to find the Spearman's rank correlation coefficient from this given data. Okay. Now we go to the solution. So what we have first, see what is given to you. We have given the marks of the mathematics and marks in the physics. For how many students it is given? So it is given for 8 students, and then we have to find out is there the rank? What is the rank correlation coefficient? So what we can have is let capital R be the Spearman's Spearman's rank correlation coefficient between mathematics marks and physics marks. Okay, so what we have R is equal to, what is R? 1 minus 6 times summation di square upon n cube minus n. So this is the formula we have. Okay, then what we'll be having here, so where ei is equal to difference between the ranks and n is equal to number of observations. Okay, so that's what we have. Okay, now if I want to calculate this di, let us calculate the table. Okay, so what will be having here? What is the value of n here? Here, n is equal to. So how many observations are given? So you can see there are 8 observations given. So here the value of n is going to be 8. Okay, so we have 8 here. Now let us calculate the table. Okay, so what we have here, consider the following table. Okay, so let's have this table. So what we want in this table, see, we are given with the x observations, we are given with the y observations. Okay, so we are given with x, we are given with y, Then we calculate R1, or you can say this Rx. Then we have this is R2. You can say this Ry, rank of X or rank of Y, or R1, R2. That will also do. And then we have D. What is D? R1 minus R2. Okay, and we want this D square. Okay, so we want D square, and that's what we have. Okay, now this table. And we are interested in only the summation of D. Okay, so we want summation of di square. Okay, so see the observations what we have. Okay, see the X observations. So we have 65, 67, 69, and 71, 73, 75, 77, and 79. Okay, so starting with 65, we can have this observation as, so this is 65, 67, 69, 71, 73, 75, 77, and 79. Now we have to think of Y observations. So what are the Y observations? 55, 46, 64. Okay, so 55, 46, 64. Now what we have here? 73, 91, and 82. 73, 91, and 82. So we have 73, 91, and 82. Okay. Now what we have? 93 and 97. Okay. So we have here 93 and 97. Okay. Now we have to give the rank. So as we have decided, maximum marks better rank. Okay. So this will be 1, 2, 3, 4, 5, 6, 7, and 8. Now, in this case of Y, we have to be careful. So 97 is 1, 93 is 2, then 91 is 3, 82 is 4, then we have 73, 5, 64, 6, this is going to be 7, and this is going to be 8. Okay. And now we want the difference between these two ranks. So the difference here is 1, minus 1. Here we have 0, 0. This is going to be 1, minus 1, 0, 0. Now square this. So we'll be having 1, 1, 0, 0, 1, 1, 0, 0. What is the sum we'll be having? The sum is going to be 4. So this is very easy. Are you able to get this one? Okay. So once you got the table, then we can use this equation 1. Okay. And hence we can say, from equation 1, we have, so what we are having here, R is equal to 1 minus 6 times 4 upon 8 cube minus 8. Okay, so that's what we have. Now, you tell me what is the calculation is and what is the value of capital R. Okay, that's great. Good. Okay, so most of you are getting it. So it is going to be 0.95 and 23. Okay, so that's what we have. Hence, we got a value. You calculated it. That's great. Okay, so we got a value here. This is going to be 0.952. So you got a value R is equal to 0.952. Okay, so we can say is is the Spearman's rank correlation coefficient. Okay, so this is the correlation coefficient between the marks of mathematics and the marks of physics. Okay, so that's what our target was. We have to find the rank correlation coefficient between the marks of mathematics and the marks of physics. So mathematics X and physics is going to be Y. And one thing you have to be careful that the rank correlation coefficient for X Y is same as for Y X. Okay, so that we need to be careful. So that it doesn't matter that whether you write X first or Y first, your value this value is going to be same. So we can have the note here. Okay, so we have the rank correlation coefficient for xy is same as the rank correlation coefficient for yx. Okay. So if the order is changed, then it doesn't matter. And also small rxy is same as small yx or smaller of yx. So both this correlation coefficient, okay, uh, that does not matter whether you consider y first or whether you consider x first. Okay, so that's why we have to be careful. Okay, so if in exam you write y series first and then write the x series, that doesn't matter. Okay, but usually we consider this one. Okay, so have you understood this problem? Do you have any doubt in this question? Okay. Okay, that's good. Okay, so let's go for the another example. Okay, so we'll go for the another example. So I hope it is easy for you to calculate the rank correlation coefficient. Okay, so let us consider some more about this. Okay, so now we need to understand here we have considered that no rank is repeated. Okay, so what happens if we have the repeated rank? Okay, so that we need to understand. Okay, so when the rank is repeated, we have to slightly modify this formula. Okay, so if the rank is repeated, okay, or the data is repeated, then we have to modify our formula as this one. Okay, so here, what we modify the formula, you can see earlier it used to be only the term 6 times summation di square, and now you have these more terms. Okay, so what you can say is where mi is equal to the ith rank repeated mi times. Okay, what is mi here? It is with rank repeated mi times. Okay, so here when your data has some same observations, okay, then that becomes the case of repeated rank. Okay, so for example, if we are analyzing the meteorological data, okay, so what we have in that data, suppose we are recording the temperature in 24 hours. Okay, so for example, we are recording the temperature in the 24 hours. Then it may possible that you may get the same temperature for many hours. Okay, so as we know, the temperature from morning we started recording, then it will go on increasing. Okay, so then by the afternoon it will be the peak, and then after that it will start reducing. Okay, so it is possible that we may get the similar observations in the first half of the day and in the second half of the day. And if the data is repeated, okay, then how do we find this? Or it may happen that in a contest, okay, two judges may give same marks, okay, to the contestants, or it may happen that the one judge, okay, may give same marks to the two different contestants. Okay, and in this case, we have to consider this repeated rank correlation coefficient, or the rank correlation coefficient for the repeated ranks. Okay, so now one more thing we have to be careful in the repeated ranks. Okay, so when the marks given are same, so we cannot say that which contestant is better, or which observation is better. So here in the repeated rank, we have to average the rank. Okay, so this is the most important point in repeated ranks. We have to average the rank. Okay, so for example, two students got the same marks, and we have to consider who is first and who is second. So here, if I consider any one of them to be first and any one of them to be second, then it will be a discrimination for the one to whom I am awarding the second rank. Okay, because the student does not deserve to be the second rank. Okay, and so many times it happens that such a tie happens, then the prize or the rank is given as to the both the contestants, and it is the average rank. Okay, so here we'll be using average rank. Okay, so now what is the procedure to calculate in this repeated ranks that we have to see? Okay, so let us see. When we have the repeated ranks, okay, so then we have the procedure slightly different. Okay, so what we have to do is we consider the procedure for this repeated rank. Okay, so here, as I said, we have to go for averaging. Okay, so once we go for averaging, okay, so here we have the procedure. So most of it is going to be the same what we did. So we write the formula for the repeated data entry to find the Spearman's rank correlation coefficient R. Okay, then as I said, we have to go for the average rank. Okay, so here is that we have to go for average ranks. Okay, and then once we calculate average ranks, okay, then we can calculate the remaining table as we did in the previous case. Okay, so only thing that we need to understand is average rank. Okay, so here this is the additional thing that we need to understand, or else everything is same as we did in the previous case. Okay, so if you have any doubt up to it, you can ask. So do you have any doubt in this concept, repeated rank? Okay, so it will be more clear again when we'll go with the example. Okay, so let us try this example. Okay. So now we'll have the example. See here, we have the next example. Okay, and you can see that obtain the Spearman rank correlation coefficient from the following data. So you can see this 13 is repeated, and here you can see this 28, 28, and 28 is repeated. Okay, so from the data itself, you are able to guess whether it is going to be the repeated rank or whether it is going to be a non-repeated rank. So non-repeated rank is much more easy, okay, than the repeated ranks. Okay, so here we have to form the table. Okay, so what we have here, we have observed that there are the same observations. So it is the case of the repeated rank, and hence what we'll do is we'll write let R be the Spearman's rank correlation coefficient between X and Y. Okay, so this is going to be the rank correlation coefficient between X and Y. And what we know is we know there are repeated ranks. So here we have see now we have to use this formula. Okay, so this is the formula that we have to use. The additional term will come mi. Okay, so here what we have r is equal to 1 minus 6 times summation di square plus 1 by 12 summation I'll have this is mi cube minus mi. Okay, upon we have n cube minus n. This is equation 1. So where what we have di is equal to difference between the ranks and what we'll be having here. What is mi? So mi is ith rank repeated mi times. Okay, and what is n? N is number of observations. Number of observations. Okay, so for this example, here n is equal to how many observations are given? You can see there are 6 observations given. So we can have here n is equal to 6. Okay, and now we consider the following table. Okay, so here how we have to consider the table. So table is as usual. Okay, so what are the components of table that we know, or what are the columns of the table that we know? Okay, so we have here x, then we have y, okay, then we have rx, okay, then we have ry, okay, then we have a is equal to r1 minus r2, and we want di square. Okay, so that's what you'll be having. You can call it DI and DI square. And here we have this square. Okay. Now we have uh, observations. Okay, so how many observations we have? Six observations. One. Two, four. I hope you are making a table with me. Okay, and the last one we want to be so now we have this table. So let us calculate what we have. Okay, so it is going to be 6, 9, 13, 13. So this data is 6, 9, 13, 13, and then we have this is 11 and 31. So it is 11 and 31. Okay, now see what is Y data. So 12, 19, 28, 28. So it is going to be 12, 19, 28, 28, 28. And here what we have 39. Okay, so we have here this is 39. Okay, so now we have to avoid the ranks. Now here we have to be careful. Okay, because there are repeated ranks. So we are first considering the ranks of X. Okay, so as we know, maximum marks better rank. So maximum is 31. So it will go rank 1. Okay, now suppose if I arrange these terms. Okay, so what you will be having these terms. So we can arrange this in this way: 31, then you will be having 13, 13, 11, then you will be having 9 and 6. Okay, so this is going to be the first, but here you will be having second and third. This is then 4, this is 5, and this is 6. Now here we cannot consider which is going to be the second and which is going to be the third, and that's why what we have to do is we have to award the rank average rank to both these observations. So average of 2 and 3, it will be 2.5, and hence we have to award this rank here. This is going to be 2.5, this is going to be 2.5. But you can see we have utilized 1, we have utilized 3, we have utilized 4, sorry, 2 and 3. Then next observation will get the 4 rank. Okay, so next we have this will be 4, this will be 5, and this will be 6. Okay, so this way we have to award the ranks to the observations in data X. And now we'll consider about Y. So what is Y here? So it is 39, then we have 28, 28, 28, then we have 19, and next is 12. Okay, so let us see the ranks of this. So this will be first, this will be second, third, and fourth. This will be 5, and this will be 6. And now the average rank of this is 3. So all these 3 observations will have the rank 3. And hence what we'll get here? So this will be 1. Okay. This will be 3, 3, and 3, because the average of 2, 3, and 4 is going to be 3. So that's why this all will have the same rank 3, 3, and 3. And this is going to be see, already we have utilized 1, 2, 3, and 4, and so that's why this observation will get the next rank. So it is going to be 5, and is going to be 6. Okay, so this is how we have to award the ranks in the repeated case. Okay, so I hope you got this idea of awarding the average ranks. Have you got the idea of awarding the average ranks? We have to average the ranks for number of observations. Okay, suppose two observations are repeated, then we'll have the average of two consecutive ranks. If three observations are repeated, then we'll have the uh, average of three consecutive ranks. Okay, and this is the change in the case when we have the repeated observations or the same observation repeated number of times. Okay, and once you are ready with this rank, then the rest calculation is easy. So here, what is the difference? This is going to be 0. Okay, so here the difference is 0, 0, and here we'll be having minus 0.5. This is again minus 0.5. This is going to be 3, and this is going to be minus 2. So easily we are able to calculate. So this is going to be 0.25. This is 0.25, and now here this is going to be 9. This is going to be 4. So what is the sum we'll have here? So it is going to be 13.5. Now we have got the summation di square, but we need to take care of this term we have calculated. We need to take care of this term also. So mi is the ith rank repeated mi times. So how many ranks are repeated here? So you can see there are two ranks repeated. One is 2.5, the other is 3. Okay, so we have what will be the m1, the first repeated rank. How many times it is repeated? So this rank is repeated 2 times. Then the second rank which is repeated, so 3 is repeated how many times? It is repeated 3 times. Okay, and hence once we know m1 and m2, whatever the number of you have, m1, m2, m3, m4. Okay, so all you have to write, and then we can write. So what we have from equation 1. Okay, we have. So what is the term you will be having here? R is equal to 1 minus 6 times summation di square. Okay, so here we know what is this sum is going to be. It is going to be 13.5 plus I'll be having 1 by 12. Okay, the first term I'll be having 2 cube minus 2 plus the second term I'll be having 3 cube minus 3. Okay, and then this term divided by 6 cube minus 6. Okay, so you can see this formula. So it is going to be 1 by 12 for m1. I'll write 2 cube minus 2. For m2, I'll write 3 cube minus 3. And this 1 by 12 is common for all the terms, or it will be there for all the terms. So that's why we are able to write this formula. Okay, and now simplify. So we'll be having 1 minus 6 times. What is this term you'll be having here? So it is 13.5 plus this is going to be 1 by 12. So it is 2 cube minus 2. So 8 minus 2, this will be 6. Okay, plus 1 by 12. So it is 3 cube, 27 minus 3. So it will be 24. Okay, and here we have this is 6 cube minus 6. So we can write here 1 minus 6 times this is 13.5 plus you will be having 0.5 and this is going to be plus 2. Okay, upon we have 6 cube minus 6. Okay, so what we are able to get here, R is equal to 1 minus 6 times. So it is going to be 14 and this is going to be 16 here. Okay, and this term I'll be having 6 common, so I can write here 6 square minus 1. So easy, 1 minus 16 by 6 square minus 1. So you calculate this value and give me this value, what you are able to get. So please calculate and give me the value. What is the value of capital R? So I hope you are able to get it. Easy calculation. Anybody got answer? Okay, Pakshal got answer. Somebody else? Yeah, Prabodh also got answer. What about the others? Others, I hope you are calculating with me. Yeah, Kalyani got the answer. Saurabh also. Okay, okay. Yeah, Manisha also got the answer. Okay, great. So I hope you got the answer. That's good. Okay, 0.542829. Okay, that's good. Okay, so here we got answer. This is going to be 0.5428. Okay, so we got answer, and that's going to be R is equal to 0.5428. Okay, 28 or 29, that doesn't matter. It's okay to have 28, 29. Okay, so both the answers are correct. Okay, most important is this 54. Okay, so that's why 54, 28, 29. It's okay. So what we can say is the Spearman's rank correlation coefficient. Okay, so that's what we have. Okay, so here the only idea was to get the repeated ranks and slightly modify your formula by this term. Okay, so we are done with this example. Okay, now we'll try the another example. Okay, so let's have the another example. Okay, so write down this example. Compute the Spearman's rank correlation coefficient from the following data. So we have X data and we have Y data. Okay, so now we have 10 observations here. Okay, now what we have to do is so we go with the solution. Okay, what we'll be having, let RB the Spearman's rank correlation coefficient between X and Y. So we have now look at the data first. Okay, so whether you have the repeated entries or whether you have the non-repeated entries. If we have non-repeated entries, then it is easy. Okay, if we have repeated entries, then we have to add the term for repeated ranks. So you can see this 71, this 82 is repeated here. Okay, so even though one term is repeated, you have to consider the repeated formula. So 82 is repeated. Again, this 71 is repeated. Then here this 75 is repeated, and moreover, I can see. So what else is repeated? 75 is repeated. Okay, that's it. Okay. So that means there are three ranks repeated now. 82 is repeated, 71 is repeated, and then again here 75 is repeated. Okay. So once we know that there are ranks repeated, so we have to write the repeated formula, and hence it will be 1 minus 6 times summation di square plus 1 by 12 summation mi cube minus mi. Okay, and here we have the denominator n cube minus n. Okay, so let this equation 1. Okay, and now we have to write what these terms mean. Okay, so where okay di is equal to difference between the ranks. Okay, then mi is ith rank repeated mi times, and n is equal to number of observations. Okay, so that's what we have. What is the value here? So here n is equal to 10. Okay, so you can see here that n is going to be 10. Okay, and now once we know this formula and this term, so we have to calculate this difference now, and hence we consider the table. Okay, so consider the following table. Okay, so now I want you to make the table. Okay, so we have x, we have y, okay. So what we want, we have x, we have y, then we have rank of x, and we have rank of y, then we have difference between the ranks, and last we have square of these differences. So now I want you to make this table and then give me the value of di square. Okay, so if your value of di square is correct, then your ranks will be correct. Okay, so I want you to make the table now and then give me the value of di square. So let us see who is able to calculate di square. Okay, so calculate di square and then give me the value. I hope you have calculated the table. Okay, have you calculated the table? You got the value of di square. Okay, so the correct value of di square is 72. Okay, so most of you got it. Okay, so that's good. So you can see the table now I have calculated is using the more mistakes than as we have calculated earlier tables having the more marks, better rank. Okay, so here I have calculated using the more mistakes, worse rank. Okay, so that now that table also you can see. Okay, so let us see. So here I have considered this to be mistakes. So less mistakes, better rank. Okay, and that's how. So that doesn't matter how you calculate this table. So only thing is that this is important. So whatever the rank you use, this will not change. So I have calculated using the less mistakes, better rank, and hence I have got a value to be di square is equal to 72. And now here you can see how many times this rank is repeated. So this rank is repeated 2 times. Okay, so I have considered m1 2. Okay, then how many times this rank is repeated? So this rank is repeated 3 times. So m2 is equal to 3. And then next rank, this rank is repeated. So it is repeated 2 times, and hence I have considered this is going to be 2. Okay, so this way, this repeated ranks M1 first rank is repeated 2 times, second rank is repeated 3 times, and then third rank is repeated 2 times. Okay, so once you got this idea, then we are able to use the formula. Okay, so what is the formula we have? This is the formula that we have, and hence let us calculate the value of R. So what we can write is from equation 1 we have. Okay, so what we'll get here, R is equal to, this R is equal to 1 minus 6 times summation di square. So it is going to be 72 plus 1 by 12, 2 cube minus 2 plus 1 by 12, 3 cube minus 3, and plus 1 by 12. This is 2 cube minus 2. Okay, and this term. So what we have, how many observations we have? 10 cube minus 10. Okay, so this is 1 minus 6 times. So this is going to be 72 plus we'll be having this is 0.5 plus 2 and plus 0.5. Okay, and here we have this is 10 cube minus 10. Okay, so calculate the value of R and give me this value of R. What do you get? Okay, that's great. You got a value. Be careful for writing the point. Okay, so that's good. Okay, so we got here. This is going to be 0.54. Okay, so we got R is equal to 0.5454. Okay, so this is the Spearman's rank correlation coefficient. Okay. Yeah, so that's what we got. Right. Yeah. So do you have any doubt in the case of repeated ranks or in the case of the rank correlation coefficient?
No, sir, no doubts.
Okay, that's great.